SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture. We shall discuss briefly on certain other important types of hydrothermal systems and the resulting hydrothermal deposit. We will be looking at the sediment hosted massive sulphide deposits, which are abbreviated as this SMS, the sediment hosted massive sulphide deposit, in kind of analogous to what we say is the volcanogenic massive sulphide as VMS. So, these deposits we call as the sediment hosted massive sulphide deposits or the SMS. They have been variously named. They were for some time they were the deposits which were known as ZX type of deposit or the syn sedimentary exhalative type of deposits, meaning that the process is not purely sedimentary, the deposit mineralization is not because of the process of sedimentation. In addition to the sedimentation in the sedimentary basin, something else or some other component is required to form the minerals, the sulphide minerals. We prefer to call them as the SMS, the way we have been naming the hydrothermal systems. So, let us have a look as to what their characteristics are. So, the sediment hosted massive sulphide deposit are a very important class of deposit, contributing majority of the lead and zinc resources of the world. The famous deposits are the very well known deposits. They are in fact distributed in almost all the continents, and they are quite rich in terms of their quantity in tonnage, contributing most of lead and zinc. The Sullivan deposit in Canada is one of the one which is worth mentioning. Mount Isa mineralizing system in Queensland in Australia, and also the MacArthur River Basin in Australia, Rammelsburg in Germany, the Iris deposits, and some important occurrences in India where there is still some debates, but there could be also included under this the Zawar, Rajpura Dariba in the northwestern India in the Aravalli fold belt. These deposits like Zawar, the Rajpura Dariba lead and zinc deposit, they also are included in this category, and they are a very important class of deposits. So, the mineralization is dominantly in marine or continental sediments, pyritic carbonaceous shale or platform carbonates, with sometimes the presence of a tufaceous horizon is also there. They are essentially stratiform in nature, as could be seen from this diagram, and this is a typical idealized morphology like the one which we showed for VMS. This is an idealized morphology for an SMS, where we see that there are some syn sedimentary basinal fault which is invariably present, and there is a brecciated zone which is also present, and there are proximal sulphide mineralization in the form of the sedimentary hydrothermal facies, where sphalerite, galena, pyrite, pyrrhotite, chalcopyrite mineralization associated here, and also a distal facies, sedimentary facies, barite, carbonate, and these are in terms of the grade they are rather lean type of mineralization or low grade, whereas the proximal one is the rich mineralization, and there are some post or sedimentary rocks. So, what exactly is observed is that the sulphide body is pretty conformable, is very much conformable with the sedimentary strata. This is like what we get in the VMS deposits. This is the pre-ore sedimentary rocks constituting of the different facies. This is the feeder pipe, and this is the vent complex this one which is shown as the cross hatch here is the vent complex, and this is how is the general morphology of the SMS deposit. They can be called a stratiform mineralization, and although the ore minerals are not exactly deposited as clastics on the basin, and they do have their limitation. The lateral zoning is prominent, but not the vertical one, and they are always associated with thin sedimentary fault. And one of the important point of distinction here is that just about sometimes a little bit of a thin presence of thin tufaceous horizon, they are not associated with any significant or prominent magmatic member or magmatic component. The morphology of the ore body could be very well seen here. This section is from the Sullivan deposit in Canada, where you could see the sulphide ore very well conformable to the sedimentary strata. So, different horizons are present, and it has a very prominent zone which is a brecciated zone here, which is shown by this. This is the chaotic brexia zone, which we just saw in a generalized morphology, and a conglomerate horizon here, and sometimes there are some basement mafic member as gabbro, which is present in the Sullivan deposit, as we see as you can see here. This is kind of a generalized conforming to the generalized morphology, is one of the important deposits, SMS deposit in Canada. So, the attributes are the typically one or more ore bodies can be multiple. The layering defined by monomeric layers of hydrothermal minerals millimeter to tens of millimeter in thickness, and the average zinc grade can be high, can go up to even 10% or sometimes can go up to even 19%, lead going to 1 to 4%, maximum 11%. And in contrast or in contrast to the VMS deposits, the hydrothermal alteration which we see is very prominent in the feeder pipe is rather very subtle in these SMS type of deposits. So, the origin is syngenetic exhalative, because we need to have some component, because this sedimentary facies that we are showing the sedimentary horizons, they may not be actual contributor of the metal, and we need to have the metal source coming from somewhere. These deposits, unlike the VMS deposits where we see or we can do fluid inclusion work, these type of deposits do not provide much of scope to do fluid inclusion work, because there is no much of accompanying gangue mineral like quartz which is present, where the fluid inclusion work could be done. So, the ore fluid temperature constant from mostly from the isotope data range from about 100 to 300 degrees Celsius, and this itself tells that a temperature up to 300 degrees Celsius can only be achieved if there is some input of heat from the subsurface, and the salinity of the fluid is rather low to moderate, 10 to 23% NaCl, that is coming from the iris deposits. So, the hydrothermal system could be visualized to be anything of a flow of basinal fluid along a pressure gradient, or could be thermally driven convection, or could be gravity driven flow. So, in this case of a flow of basinal fluid, here the temperature of the fluid is definitely is expected to be not that very high, but only that there must be some kind of a situation where the sedimentary strata have been compressed and the basinal fluid must have been squeezed out in a pressure gradient, and those fluid by virtue of their higher salinity could have dissolved appreciable amount of the metal and to have deposited in the locales as it is shown. So, mechanism of ore accumulation is rather unclear, as are the source of metal and sulphur. Paleotectonic settings in this, they are likely to be in the intercontinental rift, continental margin side of the back arc, or the passive continental margins with transected by rift, where exactly we can explain the situation of the squeezing of this basinal fluid if it happens to be a passive continental margin transected by a rift. And sometimes the metal, when we get such kind of tufaceous, even though thin tufaceous horizon, they could also be a source of the metal, or the metal could have been sourced from somewhere deeper, or more efficient the situation where we visualize the system to be a thermally driven convection, there it becomes more explainable, but situation remains a little bit less clear when the ore fluid temperature is low, although we know that a cornet fluid can always be a carrier of metal and the deposition of the metals can take place, and we see the temperature range going down to as low as 100 degrees centigrade is explainable and fits to the model. So, that is all about the information that we could give about the SMS deposits. So, this is a conceptual model for the exhalative conceptual model for SMS deposit, where the hydrothermal fluid could be squeezed from the reservoir rock, which is the reaction zone, could be RNSES, RGLSES rock. This is the hydrothermal fluid, and this hydrothermal fluid will rise, and which is shown in this is the feeder zone. Hydrothermal alteration will be very moderate or subtle here, and this is the vent complex of the massive sulphide Dexia and vent, and this is the distal, this is the proximal stratiform sulphide, and the distal which we saw in the typical morphology of the. This is one such model, but one can always imagine analogous to a situation what it happens in case of a volcanogenic massive sulphide, that there could be some magmatic activity, some volcanic activity which could be there in the subsurface providing the heat, and because this fluid has to be buoyant and has to be compressed and move through this, and also it must acquire. So, it also depends on the volume of the rock that is involved. It would require, if the metal has to be only be derived from this sedimentary pile, then it definitely would require a far greater amount of the rock to be involved and the fluid to be squeezed out from this sedimentary horizon and to be channelized through such kind of system as shown here. Here is a brief comparison of the temporal spectrum of these deposits. They, even though they range from early Proterozoic to end of the Paleozoic, so their the density of occurrence, the frequency of occurrence is far more within the Proterozoic as compared to unlike the volcanogenic massive sulphide deposits, which range in age from Archean to Cenozoic. These deposits are not found to occur in rocks which are younger than Paleozoic. The Mesozoic and Cenozoic sedimentary basins seem to be devoid of these deposits, which is the reason is not very well known why is it so, but there is an observational fact. Okay, from now we now we switch over to another very important class of hydrothermal deposit, which are the sediment hosted stratiform copper deposit, or the SSC deposit. These deposits are a major contributor of copper, possibly next to the porphyry copper deposits, accounting for 20 to 25% of the world's copper production, and more importantly they are also a resource of cobalt. And the occurrences, two important occurrences can be quoted as far as this important deposit type is concerned. The one is the Zambian copper belt in Africa, which is a huge copper bearing, essentially they are copper bearing black shales, they are reduced reduced horizon, zone of reduced conditions where metal sulfides have formed or deposited, and the other one which is shown here is known as the Kupfer-Schiefer, which is essentially a black shale, copper bearing black shale horizon, and it is a very unusual situation where this particular horizon has a total area of coverage about more than 600,000 square kilometer, distributed over about 7 countries in Central Europe, Germany, Poland, even going to the to UK, and this is a, it is not, of course, this prominent horizon which is a copper bearing black shale is not being worked, or workable mines are not there. There are definitely some very selected areas, especially the where it is exposed in Poland and some other areas where they are being very actively recovered, exploited for the metal, copper and cobalt. The ore is in reduced horizon black shale with associated continental red beds and evaporites. The association with continental red bed is very prominent and very critical to the situation of the SSC deposits, as well as the evaporites, because the evaporites bear a little bit of significance as far as the hydrothermal system in general are concerned. Most of our ideas coming from the situation which prevails in the Red Sea, where the fluid is essentially a very concentrated briny fluid, much more in salinity than average seawater, because these fluids are supposed to be derived by dissolution of these evaporite beds, which are the beds of the salt, which result because of the evaporation of seawater in landlocked basins, and they are predominantly stratiform, even far more stratiform characteristics than the SMS, and much larger lateral extent. They are fine grained disseminated copper sulfides, chalcocite, bornite, chalcopyrite, some amount of significant lead, zinc and silver. This mineralogy is very characteristic in this sense that the minerals like chalcocite or this digenite and copper rich type of minerals, which are generally observed in low temperature environments or in the supergene sulfide enrichment kind of zone in existing deposits. These are the kind of mineralogy which dominates the stratiform sedimentary stratiform copper deposits, like what we see in the Kupfer-Schiefer or the Zambian copper belt. And there is no associated volcanics, and there is prominent lateral and vertical zoning that is also observed in these ores. So, mineralogically it is a copper rich system, average copper grade varying from 1 to 5%. The proposed genetic models are this is syn sedimentary or syn diagenetic, because the syn sedimentary process, which we just seen in case of the SMS deposit, is a very efficient mechanism that during the process of sedimentation there is some extra input in terms of fluid or the metal from another source, which can make the minerals deposit along with the sedimentary strata, and the other one is a syn diagenetic in the sense that the deposit formation is follows the stage of compaction and very low temperature situation in which the minerals start to reconstitute, or some of the very low grade metamorphic low grade mineral start to form. So, the syn sedimentary is akin to an anoxic water column that is prevailing in the Black Sea, because the situation could be compared to a stratified Black Sea, where we see that the lowermost part is very reducing and using kind of environment in which the metal sulfides can precipitate and as layers. So, it could be a situation like that, the syn sedimentary, where even no extra it will only be coming out because of the very high dissolving power of such kind of water, such kind of very low and low pH and reducing fluid, which can accommodate or can dissolve a lot of metals which we see in the present situation in Black Sea. So, the ore fluid is always a low temperature fluid less than 100 degrees Celsius, but still we can put them in the category of hydrothermal. The association with red bed is important because the fluid must have been at some point of time in equilibrium with hematite, must have been oxidizing, and the appropriate pH that is constrained by carbonate equilibrium means pH need to be a little high, at least stability field of bicarbonate or carbonate. So, that such kind of an oxidizing fluid will be able to dissolve and transport appreciable amount of the metals. Salinity, as I just mentioned, as the overlying evaporite beds have contributed to the high salinity of this hydrothermal fluid and for the efficient transport of metals. The ore accumulation is in response to decreasing oxidation state of the fluid on encountering the reduced zone, which is the black shales, which are enriched with carbonaceous particles, and they create a reducing zone where the sulphides could favorably be deposited. And sometimes these sedimentary strata are also associated or overlie thick mafic volcanic, more like the source of, and which could possibly provide the metals than the marine sediments. Red beds with mafic detritus and other are the other possible source. We see even though we do not see a very prominent magmatic component here, but we see the mafic members as detritus within the sedimentary horizon, and they could possibly contribute, because we know that copper can come from a basaltic kind of a source much more than it can come from any sedimentary horizon like a shale or a sandstone. So, that could also, so the red beds and the detrital mafic components are also potential metal contributors in this kind of system, which give rise to the stratiform sedimentary copper deposits. And the paleotectonic setting, they are very much expected to be in continental rift settings that resulted in the elongated sediment filled depressions bounded by normal fault, and these SSC deposits are absent in Archean, much like the SMS seems to be controlled by the first appearance of red beds. That is one of the very significant aspect of these deposits, that they never formed in the Archean, in the where we know that the condition or because of the very low partial pressure of oxygen, the conditions were much more reducing, and which might not have been able to create a system where you need an oxidizing condition for the efficient transport of the metals and then deposition in reduced zones. So, that is how they are lacking in the Archean, and the first appearance of the red beds seems to be an important controlling factor in formation of these deposits. So, this in this particular series of the hydrothermal systems which are associated with sedimentary rocks, the another important class is the Mississippi Valley type of deposits, which are also the major contributor of lead and zinc in the world. And this diagram is a composite diagram which shows all the possible conditions in which we can see this MVT type of ores forming. Situation 1, it could be a solution collapse brexia related to karstification, that means that these are essentially the cavities in the limestone which we call them as the karsts, and there could be deposition of these sulphides, metal sulphides of lead and zinc. The situation 2 could be, it is a collapse structure resulting from thinning of underlying beds and subsurface drainage, and here it could be a facies change with or without reef at boundary relation to unconformities. Here I mean it is not exactly known whether they are related to unconformities, but there is a facies change in the sedimentary horizon and they seem to have been controlled by this process. They could be on a basement high, as on this here as it is shown here, the mud bank or the talus or pinch out kind of structure, drape kind of structure, and the reef in the limestone. So, essentially these Mississippi Valley type deposit, the MVT type deposits are characteristically hosted in carbonate rocks, and there could be many different possible locales in which the ores could be localized, the deposition of the ores could be controlled. So, the main attributes of the Mississippi Valley type deposits is they are hosted by unmetamorphosed platform carbonate. This sequence, they are just not they do not show any indication of the getting metamorphosed, and the most preferred horizon is basically the dolostones, the carbonate rocks. They are strata bound. So, strata bound generally indicates that that need not have to be seen sedimentary, or they need not have to be seen genetic. They are rather more likely to be epigenetic, that means the mineralization being temporarily different or younger to the formation of the host carbonate rocks. Mineralogy is simple: low iron sphalerite, galena, fluorite, barite. In fact, these are the deposits from which the most of the fluid inclusion data on these sphalerites have come, because the low iron sphalerites are far more amenable to fluid inclusion studies because of their transparent characteristics, and they provide important inputs to the fluid characteristics. The mineralization is prominently cavity filling type, as we have seen, whether it is a karst or it is a phase change, or the situation to be created for the deposition of the sulphides. The range in age from Proterozoic to Cretaceous, widely distributed in North America, but dominantly Paleozoic. There are some Australian occurrences as well, and this as I just said, that there are ample scope for reconstruction of the fluid characteristics from fluid inclusion studies, and the fluid inclusion studies indicate a very high density, but low temperature fluid of 80 to 220 degrees centigrade, and this deposits, the ore fluid is very characteristic in the sense that they do have appreciable hydrocarbon concentration. Generally the fluid inclusions, when we see a very significant component of methane there, and there are also heavier hydrocarbons detected, and they almost look like almost oil filled brines, and the temperature is low from 80 to 200 degrees 220. The fluid is inferred to be basinal, that migrated for long distance, and no clear indication with reef type. So, here corresponding to the penultimate point, it is very interesting. In fact, these are the deposits from which the concept of the long distance migration of connate fluid was proposed, because of the fact that the fluid characteristics did not quite match with any fluid that could possibly be generated from the host carbonate rocks, and the carbonate rocks show good degree of replacement during the mineralization, and then there are many ideas that were proposed, like whether the metal and the sulfur were carried together, or the metal and the sulfur were derived from different types of fluid, and those detailed discussion is out of scope for this discussion, but they are a very interesting case, and this hypothesis is still being held, that the Mississippi Valley type deposits are a result of. So, this would actually mean that there must have been some kind of tectonic activity could have driven the fluid out of the sedimentary horizons from one particular local, and then migration of the fluid either through a gravity type of flow or because compaction driven flow. But since they are basinal connate fluid, they will be the salinity will be high, and they could be, they are very potential metal contributor. They have lots of metal like zinc and lead could be complexed in such kind of chloride rich fluid, and these deposits also the possibility of metals getting complexed in organic complexes, like some organic ligands being more prominent in the fluid for the transportation of lead is also been proposed. Okay. So, with this we conclude the discussion with this range of hydrothermal deposits, the volcanogenic massive sulphide deposit, the sediment hosted massive sulphide deposit, the sedimentary stratiform copper deposit and the Mississippi Valley type deposits. They exhibit many different types of situations, but somehow they do have some features which can be compared, like for example, a distal type VMS and an SMS deposit could possibly be having the similar type of morphology and attributes, and so that is how they make a good case of comparing them in terms of the ore fluid, involvement of cornet fluid for the mineral for transportation and deposition of the sulphides. So, these four they constitute a very interesting and important class of deposits which have generated enough of academic interest, in addition to the fact that they have been major contributor of metals, base metals like copper, lead and zinc. Thank you.